Welcome to lesson 7.3. This lesson is actually a pretty cool one. In this lesson, we're going to learn how to do things like this, but instead of having to multiply this out 7 times, which would take forever, we're going to learn how to do it in one fast step. This is called binomial expansion. Binomial means that there are two things inside the parentheses. Doesn't matter what those two things are, as long as there's two. That's where binomial comes from. So you're taking something that has two things inside and you're raising it to a power. Now, to start us off by learning about these shortcuts on how to do this in a faster way, let's start to notice some of the patterns when we start this simply. So I'm going to start with this. So first off, anything to the 0 power is 1. That one's pretty easy. Anything to the first power is itself. And for the sake of today, I'm going to specifically highlight our coefficients that we're dealing with, all the numbers. Now, if I have a plus b squared, that's a plus b times a plus b, which, when you FOIL all that out, you're going to get a squared plus 2ab plus b squared. And once again, I'm going to highlight the numbers that we're dealing with for today. And if you wanted to do a plus b cubed, that would be times itself 3 times. Now, that would take a considerable amount of work, so I'm just going to skip ahead for you and tell you it is a cubed plus 3a squared b plus 3ab squared plus b cubed. And once again, I'm going to highlight those numbers. So, looking at this, I start to notice some patterns here. The first pattern I notice is with the letters. The first letter is always going to be the first part of your binomial to that power. Now, one way you could think of this is going to be 1a cubed b to the 0, because b to the 0 is just 1. Then for this next one, we have this 3, but then we have a squared b to the first. So you can see that the power of a is going down 1 each time, and the power of b is going up 1 each time. And we can even see that in the next one. The power of a is going down 1, and the power of b is going up 1. And then finally, where we have a to the 0 b cubed, the power of a goes down 1, power of b goes up 1. So that's one way we know the letters that go here. So really all we need to know is how to figure out these numbers. And that's the hardest part of today's lesson, is figuring out how these numbers go. Now, before we talk about how to figure out those numbers, I would like to take a little bit to try to apply what we've learned here to this problem. So I have this 4. Now here's what I'm going to do. I have a minus 3 cubed. I'm going to think of that as the same thing as this, except anywhere I see a b, I'm going to replace that b with a negative 3. So I'm just going to copy this answer I have here, but once again, anywhere I see a b, I'm going to replace that b with that negative 3 instead. So I have 1a cubed, and then I'm going to replace my b with a negative 3, plus 3a squared, replace my b with a negative 3. And then I have 3a to the first, replace my b with a negative 3. And finally, plus 1a to the 0, replace my b with a negative 3. And that's how we can use this same pattern, but start to apply it to slightly different equations. This is still technically a plus b. I'm just changing the b spot to a negative 3 instead. Now let's do that same thing to my 2a minus 9. Now this one is squared, so instead of using this one, I'm going to use this one because it's squared now. So this is the pattern I'm going to use. And all the a's are going to be replaced with 2a's. And all the b's are going to be replaced with negative 9's. So I have 1, and then I have a squared, so I'm going to replace that a with a 2a. Plus 2, a replaced with 2a, and the b replaced with negative 9. Plus 1, and then I have a b squared replaced with negative 9. And now all I have to do is simplify this. Now you can see that noticing these patterns is already way faster than multiplying this out 3 times and 2 times again, and you're way less likely to make those little negative mistakes that we all hate. So if I go to simplify this, this is to the 0 power, so that's just 1. So a cubed. This is negative 3 to the first power, so 3 times negative 3 is negative 9a squared. 3 times, let's see, negative 3 squared is 9, so 3 times 9 is 27a. And then I have negative 3 cubed is a negative 27. A to the 0 is just 1, so minus 27. We got that. Now let's simplify this one. Don't forget when this is squared, you square both of those things. So 2 squared is 4, a squared is a squared. And then here I have a 2 times 2, which is 4, times negative 9 is a negative 36. And then I have negative 9 squared is a positive 81. And I simplify one more time, so distribute this 4 in. I get 4a cubed minus 36a squared plus 108a minus 108. Distributed negative a into here, I get negative 4a cubed plus 36a squared minus 81a. And then we just combine like terms, so those go away, and I end up with 27a minus 108 for my final answer. Now, let's do one more example before we move on to finding these green numbers that I've got up here that I've highlighted. And it's this one. This one is where we're trying to work backwards a little bit. So I notice that this is x cubed, so this is going to be x to the something cubed, because that will give us our pattern of our 1a cubed b to the 0. So then I just need to figure out what spot goes here. So let's separate this out. This is 1x cubed, and then whatever b is to the 0. Don't know what that is yet. Plus, and then I use my next pattern, so 3, and then instead of a squared, this is x squared. And I have something to the first. Plus, and I have a 3x to the first something squared. And then finally, plus something cubed equals 125. So I've taken this and I worked backwards to put it into here. Now that I've written it like this, I can especially look at this last number and figure out what that needs to be. What cubed equals 8? Well, that's going to be 2. Excuse me. And I can see if I replace 2's here, I get the same thing as I have here. So 3 times 2 gives me my 6. 3 times 2 squared gives me my 12. And 2 cubed gives me my 8. So now that I've put all the patterns here, I see that this is going to be an x cubed. And this is going to be a 2 cubed. So if I were to FOIL this out, this is the pattern that I would get. And then it equals 125 is actually 5 cubed. So now we can cube root both sides. I get x plus 2 equals 5 minus 2 to get x equals 3. So now we've started to learn how to take these patterns that we've seen here and apply them to solve problems. However, we still haven't talked about how to find these green numbers that we come up with. We'll talk about that in the next video when we introduce something called Pascal's triangle. I'll see you then.